Hello everyone. In this video we'll see how we can solve LeetCode problem number 408, which is valid word abbreviation. So before solving it, let's first try to understand the problem. So the problem says a string can be abbreviated by replacing any number of non-adjacent, non-empty substring with their length. The lengths should not have leading zeros. For example, a string such as substitution could be abbreviated as but not limited to S10N. Now S and in between there are 10 characters, so we can write them as 10 and N. Now it can also be abbreviated as sub 4 U 4. So if you'll see sub, then 4 stands for these five characters, then we have U, and then again we have 4 characters. Next we have 12. So 12 is also an abbreviation of substitution, as substitution is 12 characters in total, and so is SU3 I1 U2 ON, because after SU three characters are there, then we have I, then we have one character which is written here, and then we have U, then again 2 characters, then ON. And next, substitution itself is an abbreviation since there is no string replacement. Let's see what all are not valid abbreviations. So if we have S55N, since 5 are adjacent to each other, they are not valid abbreviations, even though there are 5 characters each. Next, S010N, since it starts with 0, it's not a valid abbreviation. Next in line we have S0 substitution, U station, since there's a 0 here and it is not replacing anything, it's again not an abbreviation. So you would be given a string and an abbreviation. You have to return whether the string matches the given abbreviation or not. A substring is a contiguous non-empty sequence of characters within a string. Let's take the examples here. So we would be given an input something like internationalization and the abbreviation I12IZ4N. So we'll return true, and the explanation would be, since after I we have 12 characters, NTER, NATIO, NAL, then we have IZ, and then we have 4 characters, and we have N. So it's an abbreviation. Next, let's take this example too. The word is apple and the abbreviation is A2E, and the output would be false because after A we have 2 digits mentioned here, but we have 3 here. We have PPL in between of A and E, so it does not match the abbreviation criteria, so our output would be false. Here are some of the constraints that we have been given. Now let's see how to solve it. To solve this problem, we'll go through the 2-pointer approach. So we'll start with the first letter from the word, and we'll start from the first letter of the abbreviation. We'll run a while loop, and this while loop will go on till I and J, which is the starting point of word and abbreviation, is less than the length of word and abbreviation respectively. The first thing that we'll do is, whenever we'll receive a number, a digit in J, or the character in J, and we'll see if it is applicable as a number or not. So let's say if we get I as our first string character, we'll check if it is applicable as a number or not. If it is applicable as a number, we'll match it with the words character. So if it's not matching, if the character at abbreviation is not equal to character at word, what we will do is we'll return false, because this means that the abbreviation is not the abbreviation of that word. Else what we will do is we will increment the counter of both the words. Else, let's say we got our first digit as first character as 1 or 2 or 0, anything, so it will go to the else block because that is not applicable as a number. So in the else block, what we'll do is we'll check if the abbreviation at j is equal to 0, then we'll return false. Now why we will return false? Because we don't want any leading zeros. As you can see, these two conditions here. So we'll return false. Now what we will do is we need to capture all the numbers. So number can be single digit and number can also be double digit. As you can see, number can be 10, number can be 4, and also number can be 12. So how would we know that? To know that, what we will do is we'll have a temporary variable here, let num, and we'll run a while loop after that. In this while loop, we'll keep increasing, we'll keep adding whatever we get at abbreviation at j into num. So while j is less than abbreviation dot length and abbreviation at j is not applicable as a number. So basically, if we have j less than abbreviation dot length and it's a character, we'll keep running this while loop to capture the number. And what we'll do inside this while loop is, in this num, we'll multiply num into 10 and we'll add the number at abbreviation at j. So let's say if there's a 1, abbreviation at 1 at j would give us the string n, then number would convert that string 1 to a number and it would add it to this particular calculation, and that would give us the number. And once this is done, we'll increase the j. It will keep going on until we find a character or until we find the until we know that j we still have abbreviations length to search to. Once this is done, the number would be captured, and what we will do is we'll increase I to that number. So let's say let's take this example. In our first iteration, we'll get I will go to our if block because it is not applicable as a number, and it will be evaluated word at I. Word at I is this I, is it equal to abbreviation at j? So yes, they are similar. In our next iteration, what would happen is since we'll get 1, so 1 is applicable as a number, so it will go to the else block. In else block, we'll check if abbreviation at j is equals to 0, which is not. So it will not go in the if loop. Next, what it will do is we initialized a num, and in this while loop, what would happen is j, which is our 1, is less than abbreviation dot length, which is true, and abbreviation is dot j is not of is applicable as a number. So this since 1 is a number, so it will get inside this while loop, inside our num, what would happen is 0 into 10, which is 0, plus number, like we'll convert 1 to a number, and so 0 plus 1, our num would be 1, and we'll increase the j. Next, again, we'll get into this loop since j is less than length and j is also 2 here. J is 2, so it will come here, and we'll get inside this while loop. Since our previously our number was 1, so 1 into 10 would be 10, plus number of string 2 would be 2. So 10 plus 2 would be 12, and we increased j. In our num we have 12. Now what would happen is the j pointer would take us to I. Okay, j is less than abbreviation dot length, since this is true, and not of is not applicable as a number, and here we'll get I. So I is actually not a number. We will not get inside this while loop, and what we will do is we'll go to I, and here we'll increase the pointer of I by 12. So what will happen is previously our I was 1, now it would be 1 plus 12, so 13. Now both our j and I are at 13. It will go back to this while loop. Now it will check if I is less than word dot length, which is true, because the internationalization is the word length of nationalization is less than is greater than I. And again it will check here if j is less than abbreviation dot length, which is also true. It will now go to the next character, which is a comparison of I and z, and since here we'll get I, so our I, which is now at 13, and j, which is now at 3, it will check the character, so it will, in this line it will check if word at 13, which is index 13, which is I, is not equal to abbreviation at j, so which is not true. So it will go and increase I and j simultaneously, and it will keep going on until we find the final result. So this is how this problem could be solved using a 2-pointer approach. Now once all of this is done, what we'll do is we'll return I equal to word dot length and j equal to abbreviation dot length. Now the point of doing this is we'll return true only if both I and j have met or have reached the length of their respective words. Then only we'll return true, otherwise we'll return false. Thank you. And let's wait, before I finish this video, let's run this once. So as you can see, on both the test cases they are passing, and let's try to submit it also. Yeah, yes, so yeah, that is how it is done. Thank you.